Okay, so you're going to try this problem on your own on some scratch paper or a dry erase board, and you want to pause the video until you've sketched a graph of a function f that satisfies all of the following conditions, and identify the x value of each discontinuity and classify its type. So when you've given that a try, you can resume the video and we'll go over one of the possible solutions then. So f of 1 equals 2 means I need a closed circle on this graph where x is 1 and y is positive 2. And that will satisfy the first condition. Okay, then the limit as x approaches 1 from the left of the function f, so I'm headed from the left towards positive 1, that limit has to equal 4. Well, I can't have two closed circles at 1, so my limit is going to need to be an open circle in order to satisfy that condition. And it's going to need to have a function that's connecting or hooking up to it from the left side. Okay, so I'm not going to check that one off as complete yet because I haven't drawn that function. Then C, the limit from the right side approaching 1 is going to be negative 3. So again, I can't have a closed circle since I already have one, so I'm going to need an open circle at negative 3, and that's going to hook up to a function feeding into it from the right side. Now D, f is increasing on the interval x less than negative 4. So I go to my x's, and here's my x at negative 4, and it's going to need to be increasing, but I don't know yet from what y value, right? So rather than draw that and then have it be wrong, I'm going to come back to that one in a moment and see what E says. E is the limit of x approaching negative 4 from the left. And that limit, that y value, has to be less than the right-sided limit approaching negative 4. So coming from the left toward negative 4, I need a different and smaller y value than coming at negative 4 from the right side. So I can't, it doesn't say what values I pick. I can pick anything I want as long as the left is smaller than the right. So if I approach from the left and I want to end up, say, at negative 2, that would be smaller than negative 1. Right? So I need to make sure I connect from the left at negative 2 and from the right at negative 1. And then I would satisfy my condition E. But back to D, the function is increasing over the interval x is strictly less than negative 4. So coming for x is less than negative 4, that's coming from the left side. So my left-sided interval was the smaller one, and my function has to increase up to that point. So I'm going to be going uphill from negative infinity to my open circle at negative 4, negative 2. Okay, then from my limit approaching from the right side, there's nothing that says whether this is increasing, decreasing, or constant, right? So as long as I don't fail the vertical line test, we should be in good shape. But it does tell me up here in C that my limit as x approaches 1 from the right has to go to negative 3, from the left has to go to 4. So if I want to connect these two segments from here to here, that would satisfy my condition for B, that my limit headed from the left side is positive 4. Okay, so that would be one way that you could show that for B. Then for C, we're going to do the right-sided limit. That one's connecting at negative 3. So that means I need something on this right side of my open circle, and there's no criteria that's that I have to follow with regard to that. So I'll go ahead and make it quadratic. And now C is satisfied. We already took care of D and E. So this would be one piecewise function that would satisfy all of the given conditions. You may have made a different graph, and that's fine, as long as you satisfied all the conditions and can go back and identify each type of discontinuity. So here at x equals -4, we have a finite non-removable discontinuity. That's also called a jump discontinuity. Finite. That's a weird looking T, but it's a T. And then we've got another finite or jump discontinuity occurring at x equals 1. Okay, so don't assume that because there is a closed circle that automatically makes it a repairable discontinuity or a removable discontinuity, right? The limits would have to, from the left and the right, meet at the same value, and they do not. So because those limits from the left side and the right side are different values, that's what makes it the finite or jump discontinuity. So this produced two finite discontinuities, one at x equals -4 and one at x equals +1.